Good morning, guys. Next topics we have to sensors. So sensors has a when we are to detecting the some object, we have to detecting some object. These sensors means like a analog sensors or digital sensors is there. Analog sensors is total depending upon logic 1 and logic zeros, and digital sensors is accuracy of values and point with the point 0, point 1, point 2, point 3 up to 0.9999 up to 1 to 0 to 9. Okay, that is a digital. Okay, there are different types of sensors and different sensors, and depending upon applications in number of sensors is there. Okay, first sensor is IR sensors, second one is humidity sensors, PAR sensors. Okay, temperature sensors, next LDR sensors, vibration sensors. Okay, there is end up those sensors also analog sensors. Okay, it's depending upon logic 0 and logic 1. Next sensors you have to digital sensors. Digital sensors means totally it's converted to with point values. First one, ultrasonic sensors is a digital sensors, and temperature sensor is a digital sensors. Okay, next one, MEMS sensors also digital sensors. MEMS full form is micro electromechanical systems. Okay, we have to use it for the physically handicapped peoples. Okay, physically handicapped peoples we are using for the MEMS sensors. And next go for another sensors. And next, what is the vibration sensors, and at the same time mm, gas sensors, smoke sensors, gas, smoke, alcohol. Okay, guys, see that sensors, a sensor is used for tracking input. Every sensor has a input conditions. Okay, any sensors input, what is the output? Output is different. If you want to some application, that is the output. Okay, this is the sensor is the one of the input. It has a transducers that is converts energy from one frame to another for any measurement or control purpose. Okay, that is a, see that controlling purpose means, like examples, temperature sensors. What is the purpose of temperature? When we are to increase the temperature, automatically either fan controlling, either light controlling. Okay, that is the temperature sensors. Okay, next, actuators. So actuators is a output device. Actuator is output device. It has a transducers, that means mechanical to electrical, which converts to signals which corresponding to the physical actions. Okay, examples, LEDs. LED means light emitting diode, like a output device. Okay, not a LED for either lights, a fan or motors. Okay, LEDs, these are output devices. Okay, LED is a PN junction diodes convert to cathode and anode. Okay, LED mainly anode is cathode is there. Anode, cathode is a positive device, anode is a negative device. Anode is the positive, cathode is a negative. Okay, so that is the anode. Actuators. Next, the functions can be anode, the maximum current flow through LED, limited connecting resistors series between power supplies, and LED shown the figure below. LED is mainly positive to negative, electron through pass only for positive to negatives. So LED, what is the operating voltage? LED 0.7 to 3.3 volts in LED operating voltage. Okay, this we have to given input voltage 5 volts. Okay, after that, then how to interfaces to LED circuit diagram. So showing the below figure, there are two ways of the interfacing of the LEDs: the microcontroller or microprocessors. Okay, anode LED connections in power pin is cathode is ground connections. Okay, that is the interfaces to LED connections. Next, and any not for the like a LED, any output device we have to interfaces to, one pin is the VC, second pin is the ground. Okay, that is the output device. Next, go for communications. Already I have to discussing some communication topics. These communications means, what is the purpose of communications? Data we can transmitting, okay, one source to another source, transmitting to data one source to another source, okay. On communications, there are used for the internal communications, okay, and different between components person they are. See that, guys. Inter integrated circuit, first one, inter integrated circuit, that is the one of the protocol, okay. Serial peripheral interface, SPI protocols. Next, universal synchronous receiver transmitters, UART, that is the one of the communications, okay. Next, wire interfaces and parallel interfaces, okay. Yes, I2C protocols. I2C one of the protocols. They have to use it for the real-time protocols. Serial parallel interface has the system devices. System, we have to system interfacings, and UART. UART means total is depending upon USB cables. USB. Okay. There are communication between two modules. One modules, one PC to another per PC, or uh, one system to another systems, okay. That is a UART. Examples: inter-integrated circuits, they are the synchronous, the bidirectional, half duplex, two-wire serial interfaces developed by Philips Semiconductors on 1980s. Okay, not just synchronous. We have the bidirectional data means communication mainly simplex, duplex, two types, simplex and duplex. Again, duplex is a two types, half duplex and full duplex, three types. Full duplex is the advanced communications. Simplex, duplex is again two type, three types: half duplex, full duplex, and full duplex. Okay, simplex means only for data one way communications. Examples: keyboard or TV remote. Okay, next, duplex is the two type. One is the half duplex and full duplex. Half duplex means like a one, when we have to give an input, after that we have to receiving the some అవుట్పుట్ డివైస్, ఓకే. ఒకసారి డేటా పంపించిన తర్వాత నెక్స్ట్ సెకండ్ టైము డేటా రిసీవ్ చేసుకోవాలి, దానికి హాఫ్ డూప్లెక్స్ అన్న. ఎగ్జాంపుల్: వాకీ టాకీ, ఓకే, వాకీ టాకీ. నెక్స్ట్, ఫుల్ డూప్లెక్స్ మీన్స్ at a time transmitting and receiving purpose, at a time transmitting and receiving purpose. That is the like a example, mobile phone, okay, mobile phone. Next one, full duplex. Full duplex means like a conference calls. Now single input, multiple output, that is a conference calls, okay. It's compare the two buses, SCL and SDA, okay. Serial clock and serial data, serial clock and serial data. SCL generate of the synchronous clock pulses, and SDA transmitting the sensitivity across the devices. Okay, SCL and SDF, serial clock and serial data. Okay, serial data, serial clock means this is the I2C protocols. This I2C protocols means, see that, guys, this totally block diagrams. Each and every block diagram we have to interface into some resistors or capacitors like any bus connections. And next, peripheral interfacing communication. So the peripheral interfacing communication means communication examples. See that, guys, RS-232 and RS-485, Max 232 also one of the serial communication IC. USB, one of the wireless communications. IEEE 1394 firmware. Infrared, Bluetooth, Wi-Fi, Zigbee, General Packet Radio Service, GPRS. Example, RS-232 and RS-485. Okay, so this is the total interfacing to wireless communication. These wireless communications conform used for the DB9 connectors. Because of DB9, we have two database 9-pin connectors. These DB9 connectors we have to interfacing to module and wireless module, either controller or wireless module. That means to interfacing to RX and receivers, transmitters and receivers. So this is the RS-232 cables. Okay, is a totally entire block diagram of DB9 connectors. So you have to 9-pin connectors. This is the 25 pins connectors. So these 24 9-pin connectors we have to mainly 3 pins. One is the transmitter, one is the receiver, another one is the ground. If you want to some clock pulses, we have to use it for the another questions, another pins, okay. So this is the communication modules and sensors modules. If you have to any doubts after the lockdown, I have to explain each and every sensors and each and every communication modules. Okay, each and every ICs. Okay guys.